In this video, we are going to revise section A and section B of science paper 1 for 2022 internal here. So we are dealing with the physics paper. Now let's look at the first question. A wire has a length of 1.3 and a diameter of 0.4 millimeters. Which of the following instruments will be most suitable to use to measure the length and the diameter? So our focus is we are trying to find the instruments that we can use if we want to measure the length and the diameter. So for the length is tape measure, then for diameter of a wire, so diameter of a wire, that is just the micrometer screw gauge. So the answer for the first question is C. Now we can move on to question 2. The following diagram shows a measuring cylinder and a balance used to measure the density of liquid X. So let's look at the first diagram here, balance. So here we can see that we have an empty beaker placed on this beam balance. Then when this empty beaker was placed on this beam balance, the readings were pointing at 20, since each calibration represents a 10. So we have the 20. So 20 grams is the mass of this empty beaker. Now after the liquid was put into this particular beaker, then the readings went from 20 to 160. So we have a 100, and so that is 140. So that is 140. So now the first question is, what is the mass and volume of the liquid? So let's look at the mass. So the mass, first, for us to find the mass, we are going to get 100. So 140 is the mass of the liquid and the empty beaker. Then the mass of that liquid, we said, of that empty beaker was 20 grams. So if we subtract 20 grams of an empty beaker from 140, we get 120 grams. So this 120 grams is the mass for this liquid X. So we know that now from the multiple choices, we have the answer B. So our answer is B, since the liquid volume, we can see that here this is 60. So we can see that the mass 120 and the liquid 60 cubic centimeters. Okay, now let's move on to question 3. The following diagrams shows a stretched spring of 10 centimeters and a stretched spring of 22 centimeters when a force of 4 newtons is applied. So the first diagram here, we can see that the length of this spring before it was stretched, it had 10 centimeters. So now after a force of 4 newtons was hung on this spring, there was now the spring stretched from 10 centimeters to 22 centimeters. Now the question is, calculate the total length of the spring when a force of 6 newtons is applied. So here we can just look at the ratios. So before the 4 newtons was hung on this spring, we have 10. Then after we add 4 newtons, we have 22 centimeters. So we can see that 4 newtons made the spring to stretched to 22 centimeters. So what over 6 newtons? Okay, so what we are going to do is, let's look at let's subtract 10 centimeters from 22 centimeters. So we can see that 12 centimeters was the length that was stretched when 4 newtons was added. Now the question is, what if we now add, if we put 6 newtons instead of 4 newtons? So let's find the length that this spring can stretch. So 4 times the xn, we have 4, xn. Then here we have 12 centimeters times 6 centimeters. So if we divide by 4 newtons, also here by 4 newtons, so we can see that x is, so 4 into 4 is 1, 4 into 12, that is 3 times 6 is 18 centimeters. So when we hang this force of 6 newtons to this particular spring, we are expecting an extension of 18 centimeters. Now this 18 centimeters is not the final answer. This is just the extension that the spring exerted. So what we are going to do is we need to add this 18 centimeters plus the original 10 centimeters before the extension. So the total, we can see that T is 28. So our answer is C. Then for question 4, the motor is used to lift a load of 400 newtons through a weight of 12 meters in 20 seconds. So what is the efficiency of the motor if the input power is 300 watts? So the efficiency is equal to output power divided by the input power, then multiply by 100%. So here we have the input is given. So now let's find the output power. So we are going to say power is equal to work done divided by time. So for work done, we just say force times the distance. Then force times distance is the work done divided by T. So let's look at the force. So the force is 400 newtons multiplied by the distance is 12 meters divided by 20 seconds. So if we do math here, we cancel 0. 2 into 12, this is just 6. 6 times 40 is 240. So this is our power output. So 240 divided by 300 times 100%. So if we cancel 0, we cancel this one, we cancel this 0, we cancel this 0. So 3 into 24 is 8. 8 times 10, we get 80% as our final answer. So this is how we can find the solution for question 4. So our solution is D, 80%. Now question 5. The following is a table containing information about particles in different states. So which of the following substances is a solid? So for the first one, L, fixed pattern, yes. Close together, yes. Very mobile, no. So A cannot be the answer because the particles in a solid are not that very mobile, they are fixed. So then for M, we have random, no. Far apart, no. So for N, fixed pattern, yes. Close together, yes. Only vibrate, yes. So our answer here is C, because the particles in a solid, they have a fixed pattern, then they are close together. Then if these particles were to be heated, they can only vibrate. Okay, now let's move on to question 6. If 1,200 cubic centimeters of an ideal gas is heated at a constant pressure from 27 degrees Celsius to 127 degrees Celsius, so what will be the final volume? So here we are dealing with the gas laws. So let's look at the formula that we need to use here. So the formula, we recommend you use this, so we can say PV is equal to T. Now this simple formula can be used to derive any formula from the three given laws: Charles' law, Boyle's law, and Gay-Lussac's law. So what we need to do here is we need to make whatever that is constant the subject of the formula. So from the question, we have been told that pressure is constant. So let's make P the subject of the formula. We can divide by V, even also here by V. So we can see that P is equal to T over V. Now after making that letter the subject of formula, in our case P, where there is P, we are going to substitute with whatever that we have formed after the equal sign. So in our case, we are going to get T over V is equal to T over V. So we have T1 V1 T2 V2. Now this is same as if you want, you can write it as V over T is equal to V over T. So it doesn't matter which one is our denominator and which one is our numerator. The answer is always the same. So now after finding the formula, we can write our formula. So we have T1 divided by V1 is equal to T2 over V2. Now let's do math. Temperature 1 is 27 degrees Celsius. Now temperature must be in Kelvin whenever you are dealing with the gas law, so we need to convert 27 into kelvins by adding 273. So if we add 273 on 27, we are getting 300 over volume 1 is 1200 is equal to temperature 2. So 127 plus 273 is 400 over, we are looking for volume 2. So if we cross multiply 300 times V2, that is 300. Okay, so that is just 300. Let me create some space here. So 300 times V2, we get 300. V2 is equal to, we have 1200 times 400. So we divide by 300, also here by 300. So I can cancel these two zeros, this also two zeros. So 3 into 3 is 1. 3 into 12 is 4. So we have a 400 times 4. So we can just ignore the two zeros, we multiply the numbers, or you can just use a calculator, because in science calculators are allowed. So 4 times 4, we have a 16, then we put the 200. So our final answer is 1600 cubic centimeters. This is our volume at all, and it's making sense. We can see that the temperature 1 was 27 degrees Celsius, then temperature 2 was 127. So the temperature increased. So if you increase temperature on a gas, the volume also increases, because the two are related by directly proportional. So our answer here is B. Okay, so now let's move on to question 7. Which of the following is not an electromagnetic wave? Gamma ray is an electromagnetic wave. Infrared, it is an electromagnetic. Ultrasound, no. So the answer is our C. Ultrasound is not an electromagnetic wave, or we can just say sound is not an electromagnetic wave, because sound is a longitudinal, while all electromagnetic waves are transverse waves in nature. Now let's look at question 8. The following diagram shows a water wave. So let's look at so this point here, this is what we call a trough. Then the one on top is a crest. Then from there, the distance from the rest position, this Q, this is what we call an amplitude. So we have an amplitude. Then our P, this is our wavelength, because it is denoting the distance between two successive crests. So now let's look at the answer. Which of the following correctly identifies the amplitude, trough, and wavelength? So the amplitude is Q, the amplitude is Q, trough R, then a wavelength P. So our answer here is we have a B. So question 80, we have a B. Let's go to question 9. What is the upper limit of the human hearing? So the limit for human ears in terms of the capacity is between 20 Hz to 20,000 Hz. So the upper limit is 20,000 Hz. So now from the multiple choices, we are trying to look at the number. If we expand it, can give us 20,000. So let's look at the first one is 10 raised to the power 10. 10 raised to the power 1 is 10 times 2, that is 20. 10 raised to the power 2b, that is 100 times 2, that is 200. No. Then if you go on C, 10 raised to the power 3 is 10 times 10 times 10, which is 1000, times 2, which is 2000. No. But 10 raised to the power 4 is 10 multiplied by 10 by 10, which is 10,000. Now this 10,000 multiplied by 2 in front, we get 20,000. So our answer is D. 20,000 is our upper limit. Then for the lower limit, if the question comes on the lower limit is just the 20 Hz, like our first party. Okay, now we can move on. Question 10. The following diagram shows a ray of light incident on a plane mirror at an angle of 90 degrees. So what happens to light when it strikes a medium at an angle of 90 degrees? So now we are expecting now the reflection also to occur in the same line but opposite direction. So the answer here is A. So whenever light strikes a medium at an angle of 90 degrees, there is no angle of incidence and also no angle of reflection. Okay, now let's move on to question 11. A transparent material has a refractive index of 2.0. What is the critical angle of the transparent material? So formula for a critical angle is refractive index is equal to 1 over sin C. The C represents the critical angle. So where there is any, we can substitute with the refractive index, in our case 2. So 2 is equal to 1 over sin C over 1. We cross multiply. So 2 times sin C is 2 sin C. 1 times 1 is 1. If we divide by 2 here and also 2 here, then we have sin C is equal to 2 into 1 is 0.5. So now we need to find the arc inverse of sin C. So we shift the sign to the other side, giving us C for critical angle is equal to sin, then inverse of 0.5. So we can go on a calculator, or the sine of 0.5 is just 30, but let's look at the calculator. So we say shift, then sin 0.5. So I'm getting the value of 30 degrees. So that is the critical angle. So our answer here is A. Now let's look at question 12. A steel bar was being magnetized using an electrical method. Which of the following will increase the length of a magnet induced? A. Decreasing the alternating. No. B. Decreasing. No. You can't increase the strength by decreasing the current. No. Then let's look at C. Increasing the alternating current. Alternating current AC. AC is not used when magnetizing. AC can be used if you are trying to demagnetize, to make a magnet to lose its strength. Now if you want to magnetize an iron bar, we can use a DC, a direct current, so increasing the direct current passing through the coil. So the answer here is D. Okay, now we can move on to question 13. The following diagram shows a steel bar being made into a magnet using double touch stroking method. Then which diagram shows the magnet made? So one thing that you need to have in mind is the pole of the bar that you are trying to make must be opposite to the pole of the magnet that you are using to hit that bar. So since this each magnet has a north pole, we are trying to create here south pole. Now here I'm seeing a problem here, because we are supposed to have one end of each magnet, at least touching the bar, should be opposite to the other. Now here we have north pole here and north pole here, so there should be a mistake here. But okay, let's see what we can do. So one thing that you need to know is if the north pole of a permanent magnet striking that bar, the pole created by that bar must be opposite to that. So here we are expecting to produce a south pole, then here a north pole. So that is the magnet that we can expect from here. So we have D. Though for this question, I'm like, it's not that complete. We're supposed to have at least here south, so that we're able to create different poles. Okay, let's move on to question 14. The following diagram shows a charged polyethylene rod which is moved near end of V of the metal sphere mounted on an insulating stand. So here we can see this insulating stand. So this metal V is neutral. So the protons and the electrons are distributed evenly. Now if we bring this rod closer, what will happen? So the key point is the rod that we are bringing closer to this neutral bar has these two negative charges. So here we are going to have the charges that must be created must be opposite to whatever that you are bringing close to that. Then the electrons will be pushed away, since the electrons will be repelled away from the electrons from this charged rod, since like charges repel while opposite charges attract. So this is what we are going to produce here. So the answer for this question is B. Okay, now we can move on to question 15. The diagram below shows an electric circuit with two identical lamps L1 and L2 connected in series to a 1.5 supply. So the key point here is these two are identical. Now since they are identical, they are using each lamp here, the voltage used by each lamp is equal to the other one. So if this the first L1, if it is using 3 volts, the other one must also use 3 volts, since these two are expected, we have been given that condition of being the same or they're identical. So now which statement is correct? Both L1 and L2 will light with the same brightness because they are at the same potential. Yes. So that is the answer we are expecting. They are going to light with the same brightness. They are using the same potential from 1.5. Now question 16. The diagram below shows a circuit containing two resistors in parallel, while one in series with 2. Now the EMF from the battery is 20 volts. find the reading of the ammeter when the switch is open and when it is closed. So first, let's look at when the switch is open. So when the switch is open, we can see that we only have one loop here. So we can just say we have something like this. We have two resistors connected in a series. So the first one is 3 ohms, then the second one is 2 ohms, this one here. So if we add the two, we can see that we are getting 5 ohms. So 5 ohms, we can find the current. Let's find the current when we ignore the upper one since the switch is open. So we know that current I is equal to voltage divided by total resistance. So the total voltage here is 20 volts divided by the total resistance. Here we can see that is equal to 3 plus 2, that's 5. So over 5. So 5 into 20 is 4 amps. So when the switch is open, the current flowing through this particular circuit is 4 ohms. Now what if it is closed? So if this is closed, even the other two resistors, now these two is now working. So let's first find the total of these two resistors connected in parallel. So we can now say 1 over RT is equal to 1 over R1 plus 1 over R2. So 1 over 2 plus 1 over 2, lowest common denominator is 2. 2 into 2 is 1 times 1 plus 1. Then 1 plus 1 is 2 over 2. 2 into 2 is 1. So the total resistance for these two is 2. So if we can rearrange this, we can form now a new circuit. So here we have these 3, then we have 1. So the two resistors have been combined to form 1. So if we add 3 plus 1, that is 4. So let's calculate now the new current. So new current is equal to voltage is 20 over 3 plus 1, 4. 4 into 20 is 5. So when the switch is closed is 5. When the switch is open is 4. So the answer here is C. Okay, now let's move on to question 17. The following diagram shows a device that is used to generate electricity. So here we have this diagram of a direct motor. So which diagram shows the graph of the electricity generated? So whenever you're dealing with a DC generator, the graph that we get is this one. So you just have to put this graph into memory. Then let's look at question 18. The diagram shows the structure of an atom. So here we can see, let's calculate. So the electrons are 1, 2, 3. So we have 3 electrons. Now if we look on this center of this particular atom, we can see that we have 3 positives. So those are protons. So 3 protons, and also 3 neutrons where there is no charge. So there are 3 neutrons, 3 protons, and 3 electrons. So the answer here is B. Okay, so now let's move on to question 19. Which of the following equations correctly shows a fusion reaction? Okay, so if we add hydrogen plus this hydrogen giving us this. So the word fusion is just the joining. If two atoms join by giving us a product plus a certain amount of energy, that is fusion. Then if it would have been fission, that is splitting. Now from for B and C, that is fission because we have one, then is splitting into more than one. Then for the first one, A and D, we have the joining. So these two are our answers. These two shows the answers, but let's just go for D. Okay, let's look at the question 20. Given that the half-life of thoron is 52, how long would it take for the activity of the thoron sample to be reduced to 1 over 64 of its original value? So here there is a formula. There is a formula that we can use, and the formula is, we have this T is equal to NO 1 over 2, then it's T over half-life. So the NT represents the remaining. So the remaining after this certain period of time was 1 over 64. So we have 1 over 64 is equal to, now the original. So let's first break this 64. So instead of writing this 64, I want to write it as the base of 2 raised to the power. So 2 times 2 is 4, times 2 8, times 2 16, times 2 32, times 2. So we need 2 raised to the power 6. Then we are going to have this negative since it's a fraction. So here the original amount of this substance was 2. Then half here, instead also for half, instead of writing as half, I will just write it as okay, let's do this. So 2 times 2 raised to the power half. Then for t, we are solving for t over the half-life is 52. So since we have we can now look at the indices. Here we have the same bases, so we can just ignore this base. Then we consider the power, so negative 6 is equal to negative 1 times t, that is just t over 52 over 1, we cross multiply. So 1 times negative t is negative t. Then if we punch this on a calculator, 6 times 52, we are getting 300. So negative 312. So if we divide by negative, also by negative, we can see that t is equal to 312 seconds. So this is our answer. Okay, yeah, so we have it D. So this is how you can answer questions with multiple choices. Now, away from the first section, which is section A, let's dive into section B. Now, section B, the first question reads, figure B 1.1 shows part of a micrometer screw gauge. Then the first part, what is the reading on the micrometer screw gauge? So we begin with the main scale. So the main scale, so this is our main scale. So we can see that the last number here is 20. So on the main scale we have 20, but we just say 0.00 millimeters. Then for the vernier scale here, you need to look at the number, the line that is coinciding, or the vertical line from the main scale then up to this vernier scale. So we can see that we have a line that is crossing. So this line represents the vernier scale. So the vernier scale is 30. Now the rule is whatever number that you get here must be multiplied by 0.01. So if we multiply 30 by 0.01, we get 0.30. So this is Z. So now 0.30. So we are going to add. So we can see that we are getting 20.30. So calculators are allowed. You can just punch this on a calculator. You just plug in. So this is our final answer. Now for Roman number 2, state one use of a micrometer screw gauge. So one use, it can be used to measure the thickness of a paper. So it can be used thickness of a paper, or the diameter of a wire, a rather blade, also stuff like that. So now let's move on to this question 2. Figure 2.1 shows an object first weighed in air and then when it was immersed in water. So let's look at the first, the spring balance. It is just a balance that can be used to measure weight. So when this weight of this stone was hung on this spring balance in air, then we can see that here we are getting a 60. Then after now immersed this in water, then we can see that we have a new value of 20. So we have 20 here, we have 20. Okay, now let's look at the first question. Determine the weight of the stone in air. So the weight of the stone, we just look at the number where the pointer pointed after the stone was placed on it. So we can see that we have 60 newtons. Then define upthrust. This is just the upward force that a liquid or gas exerts on a body. That is just the upthrust. So if you place an object in water, there will be the force produced by water against the weight of that object. So the upthrust moves against the gravity, and that upthrust is produced by a liquid, or sometimes it can be produced by a gas. So we are saying this is the upward force. That a liquid or gas exerts on a body. So that is, so if we, maybe let's say we have this beaker, then if we have a certain amount of let's say water, then if we place a stone here, there will be some force of gravity, or we can say the weight of this particular stone will be pushing downward. Then also there will be another force produced by this water now pushing upward. So that is what we call the upthrust. Now Roman number 2. From the diagrams shown in figure B2.1, determine the upthrust of the water. So upthrust must be equal to the weight of whatever you are talking about. So now from the diagram, let's look at it. So before it was immersed in water, the weight was at 60. Then after immersed in water, the number reduces to 20. So there was that against there was the force, the weight of a stone was somehow reduced by this upthrust. So what we are going to do is we are going to get the 60 newtons before the immersion minus the 20 newtons after the immersion. So we can see that the upthrust was 40. So from that 60, 40 newtons was moved against by this force. So that is the answer for part 2. Then for C, calculate the mass of the stone. So mass, we say weight is equal to mass multiplied by gravity. So divide by gravity, divide by gravity. So for us to find mass, mass is equal to weight over gravity. So since we are solving for the mass of this stone, we are going to use this weight here, 60 newtons. So we have 60 newtons divided by the gravity we are given is 10. So 10 into 60 is 6 kg. So this was the mass of this particular stone. Okay, let's move on to question 3. So question 3, figure B3.1 shows a device used to measure temperature. So we know that a device that we use to measure temperature is a thermometer. Then the first one, define thermal expansion. So thermal expansion is just the tendency of matter to change in shape, volume, or area in response to a change in temperature. Sorry. So whenever you bring an object into a contact with heat, that object will change. Maybe the shape changes, the volume, sometimes it may increase in terms of the volume, also the size. So that response of that particular object in a response to a change in temperature. So whenever we change a temperature, the object must respond to that particular change in temperature. So that response of an object to change of a temperature is what we call thermal expansion. So we say is the tendance. So is the tendance so tendance of matter to change in shape, okay, let me just first do this. The space is not that enough. Okay, so we'll say so it is the tendance of matter, the tendance of matter to change in shape, volume and area in response to change in temperature. So whenever we change temperature, matter must also respond to that by either decreasing or increasing, maybe volume, area, or shape. Then let's look at B1, identify the parts about E. So E, this is constriction, and the function of this constriction is just to prevent the backflow of mercury when getting the readings of a clinical thermometer. Then for F, we have a bulb here. Okay, so now name a liquid that can be used in the device shown. So since we have a constriction, we are dealing with a clinical thermometer, and a clinical thermometer uses mercury. Then alcohol is used in a laboratory thermometer. Now for Roman number 3, mention one way in which the sensitivity of the device shown in figure B3.1 can be improved. So If we want to improve this, we can just reduce the thermometer, I mean the diameter of this glass. So by reducing the size, of the diameter of the glass. So if we reduce this, it means now it is easy for heat to penetrate since the diameter has been reduced. Or sometimes you can just say by decreasing the thickness of this glass. So whenever we reduce the thickness, it is easier for heat to penetrate through in order to reach the mercury for it to expand. Now we can move on to question 4. Two successive crests of approaching water waves are separated by a distance of 1.8. It takes 0.3 seconds for one crest to cover the distance of 1.8 meters. Question A, at what speed is the wave traveling? So let's maybe see if we can make this particular visual diagram. So we have this, like something like this. So we are taught two successive crests of approaching water waves. We may have another one if we want. So this one successive one is covering a distance of 1.8. So another one will cover the same distance. So here we have 1.8 meters. So two crests are making one wave. Then from there, each crest is also covering a time of 0.3 seconds. So for two crests, we are expecting to cover 0.6. So we just add the 0.3 by another 0.3. So now let's look at the first question. The question is, at what speed is the wave traveling? So speed, here we have distance and time. So we are not going to use the speed is equal to frequency times wavelength. No, we don't have the frequency. So we can use this formula. Speed is equal to distance divided by time. So now the distance for one complete wave is 1.8 plus 1.8. So 1.8 plus 1.8, 3.6. So the distance is 3.6 for one wave divided by, now since each crest is taking 0.3 seconds, so 0.3 seconds plus 0.3 seconds, we divide by 0.6. So 0.6 into 3.6, we get 6. So it's 6 meters per second. So for every second, a distance of 6 meters is covered. Okay, now let's move on to question 2. What distance is covered by the wave in 2 minutes? So if we make D the subject formula, distance is equal to speed multiplied by time. We have the speed we have calculated is 6 meters per second times time. Now 2 minutes. 2 minutes must be converted into seconds. So 1 minute is equal to 60 seconds. So 2 times 60, we get 120. So times 120 seconds. So we cancel the second here. So 6 times 0 is just 0. 6 times 2 is 12 chi1. 6 times 1, 6 plus 1, 720. So the distance that can be covered in 2 minutes is 720 meters. So whenever you are given time in hours or minutes, please remember to convert them into seconds. Okay, so now let's move on to question B1. So calculate the frequency of a sound wave with speed of 340 meters per second and wavelength 0.5. So what are we calculating? Frequency. So use the formula. Velocity is equal to frequency multiplied by wavelength. So we can divide by wavelength. also here by wavelength. So if we cancel, frequency is equal to velocity divided by wavelength. So the velocity, which is the speed, is 340 over what is our wavelength, 0.5. So if we divide the 340 by 0.5, so whenever you divide a number by 0.5, the final answer is just the double of that number. So 340 times 2 is what you are going to get when you divide by 0.5. That's a pattern. So 340 is 340 times 2, 340 times 2, we are getting 68, or 340 divided by 0.5. So we are getting 680. So the key point here is, what are we solving? Frequency hertz. So the key point is, if we are dividing a number by 0.5, just double the numerator. So 340, if we double 340 plus 340 is 680. Then if you multiply any number by 0.5, if you are multiplying by 0.5, just find the half. So when you multiply, you find the half. If you divide by 0.5, you just double the number. So that's a key mathematical I can share with you under this one. So we have the answer of 680 Hz. Now, Roman number 2, could this sound with the frequency calculated in B1 be heard? Okay, let's look at the limits for a human. So it's between 20 to 20,000. So we can see that 680 is within the range. So we can say yes. Justify your answer, because 680 is within the human audibility. 680 is within human audibility. So it is within human audibility, so it can be heard. Now let's move on to question 5. Now question 5 here, the infrared and radio waves are components of the electromagnetic spectrum. Roman number 1, mention one use of each of infrared radiation and radio waves. So for infrared, can be used for cooking and also in remote controllers. Then for radio wave, we can say for communication, like transmission of information from the station to a listener. So we can just say for communication. Then question Roman number 2, mention one common property of infrared and radio wave. They are all transverse in nature. They are all transverse in nature. Transverse waves in nature, or they have the same speed of light, which is 3 times 10 to the power 8 meters per second, or they carry energy, or they can travel through a vacuum. So all these are characteristics of all the electromagnetic waves. Now let's move on to Roman number 3. Give one harmful effect of electromagnetic waves. So the harmful effect of this, we can say they can make temperature of the environment to increase. Okay, then Give one difference in propagation between sound waves and electromagnetic waves. So in propagation they have specified. So we are looking at in terms of traveling. So sound wave can travel in all directions, but for electromagnetic waves such as light travels only in one direction. So sound waves travel in all directions from the source. In all directions from the source. While electromagnetic wave, I'll just EW, travel in one direction. In one direction. So the key point is like for light does not bend. So light travel in a straight line, but sound can propagate, it can move in all directions from the source. Now see, mention one factor that affects the loudness of sound wave. So loudness can be affected by amplitude. So if we change the amplitude, we change the loudness of our sound. Then loudness is just the amount of energy perceived by a listener from that particular sound. Okay, let's move on to question D. A learner sees a flashlight of lightning and hears the thunder after 4.5 seconds. How far is the lightning from the learner? Take speed of sound in air to be 340 meters per second. So what are we solving? We are solving for how far distance. So we know distance is equal to speed multiplied by time. The speed is 340 times the 4.5. So 340 times 4.5. 4 times, that is 1,530 meters. So this is the distance from where the listener is and to where the thunder, that sound of the thunder, is coming from. Now we can move on to question 6. So question 6, figure B 6.1 shows magnetic field lines between the poles of two magnets. Now, one thing about a magnet is a magnet has two poles. There is a north pole and a south pole. Then for magnetic field lines, always they move from the north pole going to the south pole. So you can identify the poles by just looking at the arrow. So where the magnetic field lines are originating from is a north pole, and where they are going to is a south pole. So from there, now the first question is here. We can see that we have, this is what we call repulsion. So for attraction can be created when we have two magnets of different poles. If we say we have north, south, north, then south. So for, if you see magnetic field lines moving from one magnet onto another magnet, here we have, this is what we call attraction. But for repulsion, we can see that there is a region between the two poles where nothing is felt. So this is what we call neutral point. And the reason why it's neutral point, because no strength of a magnet is felt, no impact. The magnetic field lines from one magnet, they are able to like cancel each, since they are of the same nature. Now if we can move on to question B, if P is south pole. Okay, so if P is the south pole, therefore this is north pole, this is the north pole, this is the south pole. That's a picture. So we have been given a point, or if you want, we can just look at the direction of the magnetic field lines. So if P is the south pole, and I mean, what are the poles Q and T? So Q is North Pole. Then T, South Pole. Okay, so this is what we can do. Too simple. Now let's move on to question 7. Now figure B 7.1 shows a graph of voltage V against the time T when charging a phone battery. Okay, so we have been given this graph. In y-axis we have voltage, then in the x-axis we have time in hours. Then A, Roman number 1, what was the voltage in the phone at the start of the charging? So the start, the initial, this is the start, so it's 2, so 2 volts. So if it would have started at 0, then we would have said 0 voltage. Now since it has a number here, we can see that there was a 2 volts in that battery of this particular phone. Then how long did it take the phone to reach full charge? So full charge is somewhere here, because from here we can see the line is now moving vertical, I mean parallel to the x-axis. So if we drop here from this graph, I'm getting about 3.5, which is 3.5, so 3.5 hours, so 3 hours 30 minutes. Then what was the maximum charge voltage? What was the maximum charge voltage? So what was the maximum charge? So from the graph here, okay, somewhere here, which is also so what was the maximum charge voltage? So the maximum charge voltage was 8.5, so I'm getting about 8.5 volts. Now from 8.5 volts, if we remove the 2 volts that the phone had before plugged in, so the amount of charged in terms of the charge that the phone got is about 6.5, because from the 8.5 there was a 2 volts before the plugging in of this particular phone. Okay, now let's move on to question B. Now question B, if the working current of the phone is 0.6 amps, calculate the first one, charge accumulated by the phone in 2 hours. So charge denoted by Q is equal to current times T. So the current is 0.6. Now T, time 2 hours, we need to convert into minutes, I mean into seconds. So 2 hours times 60, we convert into minutes, then times another 60, then we get our answer in seconds. So 60 times 60 is 3,600, then times 2, I'm getting 7,200. So we multiply by 7,200. So if we want, we can punch out on the calculator, but if I want, I can just remove 1 0. Therefore I have 6 times 7, 20. So 6 times 0 is 0, then 6 times 2, 12, carry 1, 6 times 7, so we can just 6 times 6 is 36 plus another 6, 42, 42 plus that one, 43. So this is our final answer, and the units are coulombs. Or if you can just use the calculator, 0.6 times 7,200 will give you 4,320 coulombs. That's a charge. Okay, now we can move on to Roman number 3. So this power is equal to voltage times current. So we are trying to find the power of the phone when fully charged. So when fully charged, the voltage is 8.5, because that was the voltage when fully charged, times the current 0.6. If you multiply 0.6 times, so you can punch out it. So I'm getting the value of 5.1. So 5.1 watts. So this is what you can do if you are trying to find the power. Now let's move on to question 8. So question 8, figure B 8.1 shows a coil of insulated wire wound around a U-shaped core AB and connected to a battery to make an electromagnetic. State the property of end A. So let's look at the direction of this current. So, and this is a DC, this is a direct current, because an alternating current is denoted by this symbol. So this is an alternating, but we are dealing with a direct current. So this is the direction of current. So the end where the current is entering the coil will produce a north pole. So end A will produce a north pole, will produce a north pole, produce a north pole. So that's a picture. Then where the current is leaving the core will give us a south pole. Now describe one way of increasing the strength of this electromagnet. So by increasing the number of turns on the coil. So if we increase the number of turns on the coil, we can now produce a stronger magnet. So that's a picture here that we can get. Now let's move on to question C1. What material must be used for this core? Iron. Iron is the best material. Just fire your answer, because iron is easy to magnetize. Iron is easy to magnetize. So iron is easy to magnetize. Then define 9A1, define half-life. So half-life is just the time taken for a substance to drop by half or to decay by half. So time taken for a substance to decay by half. Then Roman number 2, iodine 132, mass number 53, atomic number, decays by emitting a beta particle to produce a new element, xenon, and a gamma ray. Write an equation for this decay. So we'll begin by iodine. So the mass number is 132. Then the atomic number is 53. So now after emitting beta particle, the rules is the mass number does not change. So 132 will not change, but the atomic number increased by 1 unit. So we add 1 only, 53. So this becomes 54. Then we have xenon plus the notation for beta. Okay, then plus we can just put this symbol for gamma, since gamma was one of the product. Now give one property of a beta particle. It consists of It consists of 1 electron per particle. 1 electron per particle. Or if you want, we can just say it has a negative charge. Okay, so then he mention one medical use of radioactive substances. They have not specified, so any of these radioactive substances, they can be used to treat cancer. Then explain the effect of radioactive substance on the environment. So they can cause pollution. They can cause pollution. Okay, so this is how we can answer section A and section B of 2022 Science Paper 1 Physics. Now for section C, I'll make another video for this section. So that's it for this video. Thanks for watching.